Dear children, in the previous class we studied chapter 2 exponents, laws of exponents, that is product law, quotient law and power law. Today we will see more about exponents, that is in chapter 2 exponents. Let us learn more about exponents. So first one is a into b whole to the power n is equal to a raised to the power n into b raised to the power n. So for example, suppose a is power 3 and b is power minus 5, the whole to the power 4. You can write it as, so this power you have to multiply the each term. You have to multiply with this each term the power 4, that is a to the power 3 raised to the power 4 into second term, that is b to the power minus 5 whole to the power 4. So this is nothing but the formula a raised to m raised to n is equal to a raised to m into n. We studied in the previous class. That is nothing but a to the power 3 4s are 12 into b to the power 5 4s are 20. So this is minus 20. So I'll take one example. 5 to the power 3 into 7 to the power minus 4 whole raised to the power 2 is nothing but you have to multiply this power with each term, that is 5 to the power 3 raised to the power 2 into 7 to the power minus 4 raised to the power 2. That implies 5 to the power 3 to the 6 into 7 to the power 4 to the 8, that is minus 8 is the answer. So in that second one is a divided by b whole to the power n is equal to a raised to n divided by b raised to n. This implies, if I take one example, then a to the power minus 2 divided by b to the power 3 I'll take whole to the power 4 is equal to, so you have to multiply the whole term with this power 4, that is a to the power minus 2 to the power 4 divided by b cube whole to the power 4 is nothing but a to the power 2 4s are 8, that is minus 8 divided by b to the power 3 4s are 12. Okay, so I'll take one example. 5 to the power 6 to the power 2 divided by 5 to the power minus 3 whole to the power minus 3. Okay, here 6 to the power 2 whole raised to the power minus 3 divided by 5 raised to the power minus 3 whole divided by to the power minus 3 is nothing but 6 to the power 2 3s are 6 plus into minus is minus divided by 5 to the power minus into minus becomes plus, here 3 3s are 9. So this is the answer, or else you can write this one as 1 upon 5 to the power 9 into 6 to the power 6. Why? Because a raised to power minus n is equal to 1 upon a raised to n, that we studied in the previous class. Okay, then the third one is a to the power 0 is equal to 1. So here any non-zero number raised to the power 0 is always equal to 1. If a is not equal to 0 means it is non-zero. So I'll take 5 to the power 0 because 5 is a non-zero is equal to 1. Any number power raised to the power 0 is always 1. So it may be negative or it may be positive. So suppose minus 9 to the power 0 is equal to 1 again. And if I take 3 minus to the power 4 raised to the power 0 is also 1 only. And so on. Okay. Then fourth one, 8 to the power minus m is equal to 1 upon a raised to m, and 1 upon a raised to minus m is equal to a raised to m if a is not equal to 0. This condition applies here. Suppose this is 2 to the power minus 3 is equal to 1 upon 2 to the power 2 cube, 2 to the power 3. Okay, then 1 upon 4 to the power minus 3 is equal to, this is 4 to the power 3, because this condition applies here. And so on. Then we'll see the fifth one. Fifth one is nth root of a is equal to a raised to power 1 upon n, and nth root of a raised to m is equal to a raised to m by n. For example, nth root of 5 is equal to, so 5 to the power 1 upon 2. Here nothing is there, means you have to consider this always as a 2. That is square means what? This is square root means this is 2. Suppose if I write here 3, 5 means here 5 to the power 1 upon 3, like this. Okay, then here nth root of 3, here nth root 6th root of 3 to the power 5 is nothing but 3 is the base, right? 3 is the base. Then m is nothing but here 5 divided by, this is 6. 5 divided by 6, and so on. And you always have to remember this is minus a to the power m is equal to a to the power m if m is even. If m is even, and minus a to the power m is equal to minus a to the power m if m is odd. These two you have to remember. So we'll see some examples. Example 1 based on exercise 2b. Exercise 2b. So one is 1 raised to 0 into 3 raised to 0, or this will take 6 into 5 raised to 3 into 2 raised to 2. So this is a question. So 1 raised to power 6 is nothing but 1, because 1 if you multiply 6 times then you will get result 1 only. So I told you any number to the power 0 is always 1. So 3 raised to the power 0 is 1 here. So this is 5 cube. 5 cube means this is not 15. This is 5 into 5 into 5, that is 125 into 2 raised to 2. 2 into 2 is a 4. Here 125 into 4 is nothing but 500. 500. Then I'll take one more. Here 4 raised to power 7 to the power 2 into 4 raised to the power minus 3 whole to the power 4 here. So this implies this is 4. So this is nothing but the a raised to m raised to n is equal to a raised to m into n. So this is the formula you have to apply here. This is 4 raised to the power 7 raised to the power 2 is nothing but 4 to the power 7 into 2. That is 7 into 2. 4 into minus 3 into 4. So 4, 14 into 4 to the power minus 12. So here base is same. So you have to directly add. This is 14 minus 12 is nothing but 4 to the power 2 is equal to 4 4 is 16. 16 is the answer. I'll take one more example. Third one. So 125 whole to the power minus 2 by 3 is divided by 8 whole to the power 2 by 3. So this 125 we can write it as 5 to the power 3 minus 2 by 3 divided by 8 we can write it as 2 to the power 3 divided by 3. 2 cube is nothing but 8. 5 cube is nothing but 125 here. So here this 3 and 3, this because here this is a formula of a raised to m into a raised to n. A raised to m into raised to n is nothing but a raised to m into n. That is 3 into minus 2 by 3 I'll write divided by 2. This 3 into 2 by 3. So 5. This 3 get cancelled. This 3 get cancelled here. So 5 to the power minus 2 divided by 2 to the power 2 is equal to 5 to the power minus 2. I'll write it as 5 to the power 2 divided by this is 4. Why? Because this is 5 to the a to the power minus m is equal to 1 upon a to the power m. So this is a formula. So this is 1 upon 25 because 5 if you multiply 2 times then you get 25. This I'll write in a reciprocal, that is 1 by 4 is nothing but 1 upon 100 is the answer. Clear? Then we'll see some more examples. A to the power 5, b to the power 2 divided by a to the power 2 into b to the power minus 3. So this we can write it as this. All a terms will write a to the power 5 into a to the power minus 2. I'll write this one because why? This is a raised to 1 upon a raised to n is equal to a raised to minus n. So this is the formula. 1 upon a raised to n is equal to a raised to minus n. So that formula I am applying here. That is 1 upon a to the power 2 is nothing but a to the power minus 2 into this is b square, you write as it is. So this is nothing but again 1 upon a raised to minus n is equal to a raised to n. So 1 upon b raised to minus 3, I'll write it as b raised to 3. So this is a raised to 5 minus 2 b raised to 2 plus 3. So a cube into b 5 is the answer. Got it? I'll take one more example. Okay, prove that m plus n to the power minus 1 into m to the power minus 1 plus n to the power minus 1 is equal to m into n to the power minus 1. So you have to prove this LHS equal to RHS. First we'll see LHS part. LHS part is m plus n to the power minus 1 into m to the power minus 1 plus n to the power minus 1. The power minus 1. So this we can write it as 1 upon m plus n. Why? Because this is a raised to minus m is nothing but 1 upon a raised to formula we are applying here. Is nothing but now this I can write it as 1 upon m plus 1 upon n. So 1 upon m plus n. So here cross multiplication n plus m divided by m into n. So 1 upon m plus n into n plus m divided by m into n. This is. So this m plus n and this m plus n get cancelled. This is 1 upon m into n remain. So this is nothing but m into n to the power minus 1, which is nothing but RHS. Understood? Shall I take one more example? Take one more example. Square root of x to the power 20, y to the power minus 10, z to the power 5 divided by x cube divided by y cube. So this is nothing but, so you have to, so this fifth root of, so this x 20, y to the power minus 10, z to the power 5 whole to the power is 1 upon 5 divided by x cube divided by y cube. So you have to multiply the each term with 1 upon 5. That is nothing but x to the power 20 into 1 upon 5. So y to the power minus 10 into 1 upon 5. Then z to the power 5 into 1 upon 5 divided by x cube by y cube. So x to the power 5 ones are 5 fours are. So x to the power 4, y to the power 5 ones are 5 twos are, that is minus 2, z to the power 1 divided by x cube by y cube. Now x4, y to the power minus 2, z to the power n. This division I'll write in reciprocal, that is into y cube upon x cube. So this one, so x to the power 4 into x to the power minus 3. This x cube I'll take up, that is into numerator side, that is this plus becomes minus here. This is x to the power minus 3. So what remains is a x to the power minus 2, then plus 3, because this is y cube into z to the power 1, because the similar basis you have to write one side, that is x to the power, I'll write, sorry, y to the power 3 I'll write. This implies x to the power x 4 minus 3, then into y to the power minus 2 plus 3. So z is only 1. So x to the power 4 minus 3 is a 1, then y to the power minus 2 plus 3 is 1 again, z to the power 1. So this is nothing but x, y and z is the answer. Hope you all have understood. So please try to solve the exercise, that is homework exercise 2b. Thank you, students.